Another DraftScience video presentation. So I did receive a donation, which is nice now and then, asking the question, what is gravity? Now, I guess they're new to the channel and maybe don't know that, yes, I've already done that. But let's do it again, just for him. And just because it's fun to go over. And it's just another demonstration of how physics, the conventional story, is just so lame. I mean, so bad. And obviously the defenders won't have the conversation. I mean, I can't get a single person who knows anything about physics to attempt to convince me that, oh, they have it all figured out. It's all well evidenced, and oh, everybody who's reasonable should believe what they believe, and they're all so pretentious. You think they would want the opportunity to show me to be an idiot. But no, they don't seem to want it. And then channels that, the real talking head science guys, who do all that little show science, the people with more than 100,000 subscribers are all such cowards. The Ken Wheelers even, made the direct offer to Ken Wheeler. All he has to do is play a 17-minute video for $2,000. And he didn't take the money. I mean, the whole world is just run by gangs. And, the whole psychology of that would probably be worth a video channel now. I mean, I have learned, okay, that yes, I just, everybody calls me like a real black pillar and a, cynical, all that kind of crap about humans and this and that. And they just sit here and prove it, that I really overestimated how decent humans are. That they really are just scummy, just so scummy. I mean, these intellectuals are so dishonest. These silly rationalizations they use to defend this absolute nonsense. It's just religion. I mean, Pyrrho, for example, not a dumb human being, but just so glued to his fables that he just can't accept that the evidence doesn't support his nonsense. And he doesn't care. He just doesn't care. He's still going to sell it. He's still going to push it on little kids. You're just so creepy. He just doesn't mind. He doesn't mind maligning somebody else's character, insults, all this other stuff. And he has nothing to base it on. Just no evidence, no good arguments. Can't defend it except to change the subject constantly. I mean, such pathetic human beings. So anyway, that's worth a subject. It's just, I just didn't think, no, like 98% of human beings were scum. It's got to be some kind of number like that. It's a huge percentage who will rape the truth right in front of us. They'll just do it. They just don't care. So anyway, gravity is kind of an example of, it's not the hard sell of, they're not like they're crazy a la Muslims or something, but they're pretty bad in defense of a completely vacuous answer. Einstein spent space is like anybody could have said something that stupid. Right? You could explain how a light bulb works, and you could see that, okay, it's the inverse square law. As the light spreads into a bigger surface, it gets weaker and weaker by this principle. So you could draw the well for how light distributes just as easily as you could draw, for bent space. Bent space is a non-answer. It's a description of what it does. It's not a description of how it does it, why it does it. And if, I just said something silly like that, well, the space is bent. There's this geodesic, and it just forces the light to go out. And gravity's just saying somehow objects are forced to move towards. By what? There's no mechanism, nothing. They know somehow nothing is bent a specific way, and it motivates them. It's nothing as an answer. It's so empty. So anyway, it is a challenge to answer the question, but, instead of looking for the real answer, they just gave up and said, well, let's just accept the cartoon answer. The answer doesn't say a damn thing. It took me years of pondering it to find these. The answer is so simple. It's almost embarrassing how simple the answer is. So the idea is that the Earth is forcing things to do this. It's forcing things to move towards it. And it's doing it by, the arrow is big here, and the arrow is little here. The further away you go, it's less motivation. So lots of motivation close, little motivation far away. And it's basically because it's spherical. Okay, it spreads evenly and it diminishes just like a light bulb, but in reverse. Okay, so the light bulb gets weaker further away going out, right? And it's strong close. You're close to the light bulb, lots of photons. Far away, lots of space to cover, fewer photons per square inch. So same exact principle, just opposite. Convergence versus convergence versus, anyway, it's not really a divergence, right? It's better explained as some mechanism that pushes out. But anyway, so you have to figure out, why is the Earth, somehow something is happening in the relationship between space and objects with mass, okay? Something's happening that's causing there to be a differential, that somehow more goes in, right? So if we said there was a pressure, we can certainly say, okay, we get the pressure part because it's, less pressure far away, more pressure close in. So a certain amount of energy goes into the Earth and less, just a little bit less, comes out. Okay, and depending on how big you are, that's how much less comes out, right? So, and that's basically what we're stuck in. So we stand here anywhere on the Earth, and everywhere the same event is happening. More is pushing down, so there's more rain, you could say, rain, coming down on us, and less rain coming out from the Earth. Okay, less stuff comes out from the Earth, and therefore we go where the pressure pushes us. Pretty simple, that's gravity. That certainly does explain it. And so, that's all you're trying to explain, is something pretty simple. So if you understand that when the energy, okay, so I'm saying the universe is full of energy, so this is another pretty easy one. I just mentioned light. So there's photons hitting you all the time. There's radio waves, all kinds of stuff that we don't necessarily detect with our detectors. Our detectors can't detect unless we're tuned to the channel and all that kind of stuff. So we know we're getting hit by a ton of radiation all the time. Everybody right now is getting hit by microwaves from cell phones. They're getting hit by all kinds of stuff, all kinds of energies hitting us. And space is like that. So if you're just in the middle of space somewhere, you're not in a vacuum. There's not nothing happening. There's all kinds of star radiation hitting you, all kinds of it. And I would argue there's also kinds that we can't detect at all, okay? Because it's not the only kind of electromagnetic radiation, if we want to call it that, we can detect is the stuff at a frequency. So somehow the stuff has a frequency. It's at a specific distance in time, and it's moving in some arrangement towards us, usually with polarization, so it's a little out of alignment. But that stuff is the stuff we detect. Well, if I break that, and I break the frequency, and I put it here, you know what I mean? So it's not the same frequency. We can't detect any of that. So there could be a whole bunch of stuff hitting us that doesn't have any distinct pattern, and without a pattern, it still hits us. It's still the same stuff. It's still frequency, so to speak. It's just the frequency isn't consistent, and therefore we wouldn't know anything about it. We don't even have a detector for that. Well, I guess I'm sort of arguing we do have a detector for that. There, I just detected it. It's gravity. So anyway, we're getting hit by a ton of energy, and the fact is we're radiating back. We have to. I mean, what are we going to do with all that energy? We can't just keep it inside. We can't just collect it. So we basically reflect it in a sense. We readmit it back to the universe. And the simple argument is more goes in than actually comes out. And so what would be the mechanism? I would offer this as a simple explanation. So if you understand the universe, all the photons are made out of little bits of energy. So a photon would really be, a frequency, something like this. Each bit's moving this way, and that is what we would call a photon. Okay, so we could just change the distance between them, and that changes the frequency. So blue photon would look like this, close together. Red photon would look like this. Okay, not very complicated. They're all running parallel here. And that's why photons can get broken. I did this whole thing in the two-slit experiment and explained all of that. So that's why you can break photons and remake photons. It's because they're a composite object. They're made of little pieces, and you can rearrange the little pieces and make a different photon out of it. So that's the understanding, is that there's little bits of energy moving the speed of light. So little bits are moving the speed of light. And that's what we're getting hit by. So all these arrows just represent a bit of energy. Again, it can be in the form of a photon. That is, it can have a bit, and then a bit, and then a bit. Okay, with an exact frequency. Or it can just be a single little bit, single little bit, single little bit, little bits. And they come, and then inside the matter, the electrons and protons are what's going to do the action. Now, charge means that there's really two kinds of bits, and there's two kinds of charged matter, but we don't need to understand charge to understand gravity, because gravity really isn't electrical, really isn't charge-based. The real concept is that you just have to understand. So if I had an electron or a proton, and I hit it with a bit of this energy, the simple idea is what's going to happen is that bit of energy hits it and it moves it. Okay, now there is a second option. So if the wrong bit, if a piece of proton energy hits an electron, well, then it just gets diverted. So this just reflects in some right-hand rule kind of way. So, but we don't need to go into that. I mean, real physics is going to have a few layers to it, okay? It's still really simple, but I'm just saying it is going to be 2 plus 2 plus 2. You're going to have to be able to add 3 numbers. And 6 isn't going to have to be too big a number for you. But anyway, so what happens in the case that's significant to gravity? In the case significant to gravity, the little bit of energy hits the matter bit. Now, we know that the bits of energy are all going the speed of light. But we also know that electrons don't do that. So when it's pushing the electron, so now they're moving the electron to some new location, it's not moving the speed of light. So this distance, it doesn't travel at the speed of light. It travels something slower than the speed of light. The little bit of energy can't go the speed of light while it's pushing matter. And the simple truth is that little loss of time, okay, moving slower, means the photon's total momentum has been reduced. Because instead of being here in the universe, where it should be, it's still here. Okay, so you can understand that it lost this much distance in its activity in the universe just by pushing that electron. And that's a real loss of momentum in the universe. You can understand if I could take if I could retard the progress of a bunch of electrons bouncing in a box, and they had a certain energy, or photons, or whatever you want to think of, bouncing around in a box, and I could retard their energy. That is, I could mean they would be going this far in a certain amount of time, and then now they only go this far in the same amount of time. That means their velocity has actually been slowed down. So if I slow the velocity of something in a box, it hits the sides less, there's less pressure, there's less heat, so there's less energy. And so I have essentially taken some energy out of the universe by retarding the progress of this little tiny photon. The universe is a colder place by a little tiny bit because this little piece of activity has been lost, this distance has been lost. And that's a thermodynamic, consistent with thermodynamics. That makes sense. Yeah, okay, the universe is, so you could say the energy was destroyed. Technically, the electron moved. That's significant, matter moving. But it's only significant if the matter actually does something to the rest of the universe. And the fact is, it will be doing something to it. But anyway, let's get to the simple principle. So the electron moves, and it moves with this little force bit until it's acted on like in a Newtonian way by an equal and opposite force, or at least an opposite force. So until something comes from here or here, so another bit of energy, comes at it from not the same direction, but from an opposite direction. I'll do the opposite direction first, and then we'll do the same direction. So if something hits it that has a component in the opposite direction, like some component, on that side of the 180-degree line, then what's going to happen is the electron's going to stop, because what's going to happen is that little bit, so let's say it was this one that hit, is going to reflect, and this one's going to reflect. Like they hit each other. The matter is essentially providing an opportunity for this piece of force and this piece of force to collide with each other. They're using the piece of matter as a conduit, right? So just imagine there's a force coming this way and a force coming this way, and they both are hitting while they're both connected to the object, and they reflect. But now the object doesn't have anything pushing it. So I reflected this one, okay? And I reflected this one, which is really saying that I continued this one's path by going, so it moved the electron to here, the little piece of force, and now the force is going to continue its path that way, the direction of the reflection, right? So it lost a little time from here to here, but now it's going back at the speed of light again, because it's not pushing an electron. And the other force that was going this way is now going to continue its voyage here. So we have we've kept the continuity, we've conserved the momentums, the angular and such, the universe is at peace again. So now the electron is now just sitting there, not moving, because nothing's pushing it right now. But we know another force is going to show up and do exactly the next thing. So the next force that hits it is going to push it this way. And then the same thing will happen. It'll stop again, and then another force will hit it and move it this way. And that continues on and on all the time. So whatever the bias in this field, that is, whatever bias we hit it with a laser beam from this direction, so there's a few more arrows coming from this way than the rest of the universe, well, we know that it'll herky-jerky its way in this direction, that it will migrate this way. So instead of just jerking back and forth in even pressure, because I've added some uneven pressure, it's going to move in the direction of the uneven pressure. And as it does that, it's going to absorb the energy of that uneven pressure and all that kind of stuff. But that, if I add extra, that's not gravity. See? So gravity is what the universe is producing. So the gravity isn't, the object doesn't have gravity. The universe has the force. It provides the energy. And all the matter is doing is by going this way and going that way and going this way and going that way, that little electron is converting things going the speed of light this far into things that only go this far. So it's constantly absorbing the energy. So a little bit of energy pushes this way, a little energy pushes that way, pushes this way, pushes that way, pushes this way, keeps doing all of that. And that means that the energy that went in was doing this, and the energy coming out is a little, like I just said, we lost a little bit of it, so it's behind, okay? It has lost a little bit of its heat. So matter is like a heat sink. It absorbs the energy's heat, and it just doesn't give enough, it doesn't give it all back because it's busy moving stuff back and forth, jiggling it around, blah, 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 all kinds of directions. And that is a use, that's work. So it's consumed energy out of the universe by making matter do this stuff. And so it's conserved in the sense that the matter has to move. The energy is conserved. It's just that the work isn't productive. Okay, doing this doesn't create a new universe, so to speak, if you can get me. The only thing it creates is the gravity. But it doesn't, it doesn't make a distinctive pattern. It doesn't make something that we identify as constructive work. You could go to work and just walk around in circles, right? Somebody could pay you to just walk around in circles. It obviously doesn't heat somebody's house. It doesn't do anything. It doesn't make cars go faster. It doesn't make any useful. It's not a good use of the energy. So yeah, maybe this isn't constructive work, but it's still work, and it consumed energy from the universe. And the key fact is the person on the surface sees it. Okay, he's going to experience the deficit. Less is going to push up because there was atoms, pushing stuff every minute. There's each one of these pieces, each one of these electrons. One electron's moving this way, one's moving this way, one's moving this way. Every millisecond, they're moving in all kinds of different directions, absorbing energy in those directions. And so there's a bunch of them between you and the other side of the Earth that have, if in fact, gone this way, gone this way, gone this way, and absorbed energy in that direction, and you're going to feel it. Now, the energy absorbed in this direction, right, the opposite direction has just as much energy absorbed. Well, you can't feel it because that energy is going this way. Obviously, you can't feel it. But the guy in Guam or whatever, China, he's going to feel that energy. And the energy that actually pushed you down, right, the extra energy that made you, when you move into the Earth, when you're getting pushed into it right now you're getting pushed into the Earth, you're moving electrons and protons. The very fact that you absorb that energy is going to help keep the other guy on the other side of the Earth on the Earth. You're actually providing the used up energy. You're providing the shadow that he's going to fall into. And likewise, he's doing the same thing to you. So all the mass is contributing. And the more mass you have, the more energy you can sink. The more speed you can take out of the force. So the more energy, the more speed you consume. And that's why there's a higher differential between out here, out, and in. Okay, there's a higher and higher differential. The more mass you have, the more the differential, the stronger the imbalance gets, the colder this gets, so to speak, compared to this. So the universe has a temperature, and the object sort of has one, and the object is absorbed temperature in a sense, and that's it. That's why the center of the Earth is molten. It's because it's basically absorbing energy out of the universe. That's part of the absorption process. That's molten means there's lots of movement. So that means it's creating gravity. So I would argue that all the big objects are liquid in the center because they are moving a lot. Lots of movement going on. And that's creating the gravity. So that's the sensible answer that explains the phenomenon. Now, this creates an incontinuity, something that's not consistent with how we believe the universe works. And so I'll go into that briefly. So it fits. It solves lots of problems. It gets rid of all these aberration problems, problems where people would say something like, the gravities don't match because they think gravity is some sort of, they think it's happening, only because you put another object in the field. See, they don't think the gravity is happening all the time. So if you create all the time gravity, then you don't have to worry about arguments where they go, well, the object's moving, and if this thing's creating gravity to this thing, then by the time, it takes a long time, in the case of the Earth, to get to the sun, 8 minutes, and for the sun to send back its signal, the Earth would end up being over here, and so the gravity would be in the wrong place. Well, this object doesn't create the gravity this is creating. This is creating gravity even when there's no Earth here. Right? The sun is creating gravity, creating a differential, more energy going this way than going this way. It's creating that differential all the time because the little pieces are jiggling all the time. They don't need something to show up and say, make gravity now. The gravity's already there. Okay, so everything falls into gravity being created by matter that's moving inside the object. And so we don't need the Earth to make gravity. We don't need an asteroid or any of that stuff. So that's one of the problems. Now the other problem is if you have a universe that's full of energy, you can figure out, if you think about it a little bit, that if I move the object into the energy, I hit more stuff coming at me. So the more I move, into it, okay, the more energy I hit. If I move this electron this way, it's going to hit more stuff in the direction it's moving than it's going to hit stuff in this direction. Because even though this stuff's moving the speed of light, you're still moving away from this. So it has a harder time hitting you because you're moving, some portion of its speed is cut out because you're moving in the same direction. You're already moving 30 miles an hour, so something it's got to do that extra 30 miles an hour to be able to catch up to you as fast as it would if it were standing still. And obviously when you're moving into it, if I move into somebody shooting bullets at me, I'll hit the bullets, okay, much sooner than I would have hit the bullets if I just stayed still. So I'm going to collect more bullets in a unit of time in the direction that I'm moving, and that's going to be called drag, or you're going to be, it's a drag for a lot of reasons, but you're going to be dragged to a halt. So when you move, you're going to stop moving because you're moving into force. Now the truth is this actually does happen. So as much as it's not intuitive, like we see a wrench, and the wrench, continues to fly through space, even after, I can throw it into space, and it just keeps going and going and going and going. So we have this notion that once you make an electron move, it just keeps going like a wrench. But the actual experiments indicate that it doesn't do that, that it actually is dragged to a halt. You can't shoot electrons through space. I can't shoot an electron gun towards the moon and hit the moon with the electrons. I have an electron gun, and I shoot out electrons, with a little charge plate, plus or minus, and I shoot the electrons, and they won't go. They have a certain amount of momentum, and that's it. They run out. And the same thing with protons, single protons. So we know we're not getting hit by any electrons from space. Not free, okay? Now the fact is there are some electrons around the Earth, but those are because atoms go in towards the Earth and they hit the magnetosphere and they hit different things and they break the atoms into pieces, and then we get some electrons. But there are no electrons that come from deep space and hit us. There's no electrons from a sun far away coming all the way through space and then hitting us. No protons all by themselves hitting us. So this, this doesn't happen. And it's true that we can't shoot them. There's no experiments that'll show us shooting electrons hundreds of miles or even a mile. They ought to use LIGO for that, actually. See, they have a nice vacuum chamber at LIGO, and it's a mile long, and they ought to try to see how far they can shoot an electron in there. And it will kind of prove the point that they won't be able to get any from, shoot one here and then get the electron to travel a whole mile and land on the target. It just won't happen. Anyway, there's no evidence of it. I'm just saying I can't prove it, but they can't prove the opposite. So anyway, I need to serve a water. I'm not sure. So the truth is that electrons and protons do obey the drag rule. They do go into the force hits them more, and that means they stop, and they can be restarted again and all that kind of stuff, but they can't maintain momentum. They can't just keep going into the greater amount of force. The force neutralizes their momentum, and they cease to travel in that direction unless you apply more force to keep pushing them. You have to keep pushing them, like with a laser beam or something. You have to keep pushing them to keep them going. You have to have a constant source of energy to push them against the drag. Now, the catch is that helium nucleuses, okay, which you could say is an arrangement of electrons and protons, they can be thrown across space. We do get those from other suns, okay, and I guess they're in the category cosmic ray. But anyway, they get here to Earth, from very far away in the universe, and they have a lot of energy. They're moving rather quickly, and then they hit the atmosphere and they hit the magnetosphere and the radiosphere and the sphere, all these spheres, and in that process they break, and then we get electrons and protons, muons, different kinds of things that they have labeled, ends up hitting us as radiation because these get broken. All right, so the key is that the helium nucleus can do what the wrench does. It can go through space. It can keep tumbling and tumbling and traveling and traveling. And I would argue the reasons why is this is where you need to sort of understand the charge argument. So I probably should find another color. So I'm arguing that there's two forces. And if I did actually arrange a proton and two electrons, or two protons and an electron, however you want to look at it, it doesn't really matter. So we'll call this minus, and we'll call these. And I had a force, going back and forth through here, that was holding them together. So when electrons are in space next to each other, the whole trick is that the force reflects back and forth between the electrons. The electron force bounces between electrons, and the proton force bounces between protons, and so that creates the repulsive pressure. You can understand that if I bring them closer together, I increase the number of times the little bit hits. And the catch is that if I throw a proton force at an electron, it just deflects. And if I throw you can see that. And if I throw an electron force into a proton, it just deflects. So it doesn't have any influence. It doesn't cause any momentum. So they can't get trapped between. They always get pulled out. So if I had an electron force here, this is a proton in this example, and the proton force is between it, the electron's going to just deflect at 90 degrees. So you're going to understand that the force could just end up doing this, back and forth, back and forth, back and forth, back and forth, back and forth. Now what's that really causing? Since this doesn't create any momentum, it churns it, and it doesn't move. But these do. Every time I hit it, I'm giving it energy in a direction against drag in this direction, or any one of these directions actually. And you can understand that it's going to push it this way. And this is going to push this one this way. So this has got energy pushing it this way. This one's got energy pushing it this way. This one isn't getting any energy. And the proton and the electron are attracted to each other because they're, basically, the blue force is leaving the electron and the red force is leaving, So anyway, so it's held together as a nucleus by the charge forces, and I'm just illustrating one of the charge forces. So one of the charge forces is trapped doing this. So you're going to understand that if I apply any pressure, first you're going to understand that if it's going in this direction and this direction, if I add those two directions up vectorially, okay, they're going to add up to this direction. All right, that's going to be the net effect of going this way, and going this way is going to be going that way. So I'm going to create energy going this way by pushing that way and that way. And you can sort of understand that if I apply pressure, that is, I run into more energy going this way, that means this would get closer to this, and this would get closer to this, and that means this energy happens even more often. This reflections speed up even more bangs, bang, 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 bang. So it's a bang, 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 bang when it's here, and then it's bang, 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 and it gets higher and higher. The pressure gets higher and higher. The amount of hits gets higher and higher the closer I bring those electrons, protons, to the electron. So the closer they get to the bender, the higher the rate of impact, the more pressure to go out. So any drag would have an opposite reaction on this mechanism and cause it to push even harder in the direction. So the more it hits extra energy, the more it pushes against the extra energy. So it ends up being a kind of little motor, and it moves towards extra pressure. So if there's some way you can make extra pressure, it's going to move right into that extra pressure in a sense. And so this would be the mechanism that happens inside the wrench. The wrench has a bunch of nucleuses, that are basically helium atoms. Helium nucleuses, as part of their nucleuses. And all of them have an orientation and a direction. And if you don't give it any, momentum, then they're all in different directions and it's no big deal. But as soon as I force it, as soon as I apply force on it, I start rearranging those things, almost like magnetic domains, I start aligning them all. And then I start creating a bias in a direction. So I basically turn all of these things to start pointing in the same direction. So I take the ones that are pointed this way and this way and this, all different directions, and like magnets, I change their disposition so they're all pointing the same way, and that's what gives something velocity. So if I get this thing to go thousands of miles an hour, 200,000 miles an hour or something, it means I've turned a lot of these nucleuses have been turned and are all pointing in the same direction, and they're providing an awful lot of momentum in that direction. So the wrench in space is fundamentally different than the wrench, say, in a stationary place. Now, we don't know which place is moving, Earth or the rest of space, so it is still relative. We don't know whether the wrench flying through space is, well, we sort of do know. I mean, unless we believe the whole universe is moving, we kind of know that, yeah, the wrench you throw into space has actual momentum, and more of it is aligned than what's really happening on Earth. I mean, even though we're moving in all kinds of directions in space, we know that all those directions are just in that space, and in other places in space the directions are going to be different because different forces are acting on the objects. So the further away two things get, you can be pretty sure the space that's affecting them is quite different. And if something's moving through that space and both of those objects see the same thing, then there's real momentum in that object. So the more reference points that agree on the position of a wrench going through space, the more likely it is the wrench has the actual velocity. But I don't want to get into relativity because that's just silly talk. But so anyway, so that's probably enough of an explanation of gravity, right? So the key is that one of the arguments against, hundreds of years ago, this idea of particle gravity was thought of. They really couldn't do the whole atomic structure. They couldn't really do it in an elaborate and smart way. And so it had these arguments you could make against it. And the fundamental argument was this drag argument, that there's no mechanism for something to be able to overcome drag. Now, even though they saw in space that it was true, that drag wasn't a problem, instead of tackling it from the presumption that, well, let's just say, can we think of some reason why drag isn't a problem, they just didn't try to do that. They just gave up. And like I said, the answer isn't that complicated. You don't need too sophisticated a mechanism to overcome the drag. So it's just disappointing that physics just really doesn't want to give theories fair shot. They choose one, they tend to like it, and then they just do this bandwagon thing. So it's almost like the same way religion works. There's a bunch of religions in there. People have superstitions, and they just find the one that the most people agree with, and that becomes their dogma, and they just will not stray from that dogma. Once they've chosen it, they will not unchoose it. And that's just sad. It's just sad that humans haven't grown up enough to know that they have to be really careful that they're believing something for the wrong reasons. And it's clear that bent space is a superficial and incomplete answer. It's not even compatible with the quantum mechanics. The whole other branch of their physics is completely incompatible with it. It has every indication of being a bad answer, an incomplete, insufficient answer, and they still cling. So clearly this explanation will be consistent with quantum mechanics, at least the mechanical parts of quantum mechanics. Entanglement is just another silly story. Heisenberg, things not knowing where they are, all of that is just mush. All of these little bits of energy in discrete places in three-dimensional space, so are the electrons. All there is 3 dimensions of space. There's no 4th dimension anywhere. There's only room for 3 dimensions. The rule of a dimension is a right angle. Right angle. Okay, right angle. Every dimension is a right angle to every other dimension. All 6 of the sub-dimensions create right angles to each other. That's the rules of a dimension. So you can't say, I have a fourth dimension over here. No, you can't have a fourth dimension because you can't make right angles to the other three dimensions. So there's no such thing. There's only three physical dimensions. Everything's in a place in that space. And the rule is this stuff just has momentum. It has movement. And when the little stuff hits the little bit bigger stuff, it makes the little bigger stuff move. When the little bigger stuff moves inside a collection of little bigger stuff, the entire atom moves. Atoms stick to each other. You have a clump of atoms. They move. And then you get into this, puppy dogs and kittens and, all kinds of different size rocks and whatever. And all of them move. And it's always momentum. Okay? All it is momentum. All the way down. It's momentum all the way up and all the way down. And you don't really need to understand any other concept. It's just stuff moving. And the stuff moves by rules. The force bits move at the speed of light. And everything else is a byproduct of that stuff hitting matter. The force hitting the matter. Okay? Force hitting electrons and protons. Everything else is a consequence, direct consequence of that interaction. Stuff moving the speed of light, hitting stuff not moving at all. Okay, that needs to be pushed. That has to be pushed to the place it goes. All right, that's enough. I should sell these, right? I should yeah, that's what I should do, right? Yes, I should take images of that and sell it. But yes, the truth is in there, so that's the funny part. It's all, you saw how simple it was made. It doesn't look simple now. It looks like a complete mess, but you can see, there's the wrench, and there's the heat, and, it's all in here. So, yeah, you know how simple that was. If I show that to somebody, they're not going to say, gravity. No chance. But that is gravity. It does explain it. So anyway, enough of a video. And, we'll call that enough. And so thanks for the question. And what went with it. Appreciate it. And, I will endeavor to persevere and such. So, till the next time. And such. This has been a DraftScience video presentation. Such.